Welcome back everyone. Today's topic for the discussion is Introduction to GSM, Global System for Mobile Communications. As part of the agenda, let us look at the key objectives of GSM. Then we will see various frequency bands or spectrum that is licensed to be operated by GSM networks, and then we'll discuss on various services that are offered by GSM networks, and then we'll look into high level network architecture that enables offering various telecommunication services to mobile subscribers. And finally, we'll close the discussion by looking at key security considerations. In the previous video, that is Introduction to 3GPP technologies, we have seen various 3GPP technologies such as GSM, Global System for Mobile Communications, UMTS, Universal Mobile Telecommunications System, LTE, Long-Term Evolution, and 5G, and how they are advancing the world of mobile communications. When it comes to objectives of GSM, there are primarily two aspects to it, that is regarding services being offered to users and the overall system performance. Let us look at the objectives which are related to services to users. GSM system should provide both voice and non-voice services and facilities that are compatible with already existing fixed networks such as public switch telephone networks (PSTN), integrated services digital networks (ISDN) through the standardized access to these networks. GSM should also provide certain services and facilities that are exclusive to mobile stations, which are not feasible in the case of fixed networks, and also compatibility of access to the GSM network to any mobile subscriber in any country which operates the GSM system. Also, GSM network should facilitate automatic roaming, locating and updating mobile subscribers. GSM network should provide subscribers a service with a good quality level matching to fixed networks. GSM network should provide services to a wide range of mobile stations, including vehicle mounted stations, portable stations, and handheld devices. Performance related objectives include GSM network should provide high efficiency from the radio electrical spectrum, as the available radio spectrum is limited. GSM networks should offer attractive economic cost in terms of both infrastructure to set up and maintain by mobile network operators and mobile equipment affordability by end users. Considering GSM system uses air or radio interface as a transmission medium to exchange information between mobile stations and radio part of GSM network, there are different radio frequency bands that are identified for this purpose. There are many frequency bands that are supported by GSM. However, GSM 900 and GSM 1800 bands are popular and are extensively implemented across the world. In GSM 900 band, system is required to operate in the following frequency ranges, that is 890 MHz to 915 MHz for mobile phone to transmit and base station to receive, which is called as uplink frequency range, while 935 MHz to 960 MHz for base station to transmit and mobile phone to receive, which is called as downlink frequency range. When it comes to GSM 1800 band, mobile phone uses a frequency range of 1710 MHz to 1785 MHz for transmission to network, while 1805 MHz to 1880 MHz for receiving from network. So in GSM 900 band, 25 MHz frequency spectrum is available, that is 890 to 915 MHz for uplink communication and 935 to 960 MHz for downlink communication, while 75 MHz frequency spectrum is available in GSM 1800 band. These are called licensed bands or spectrum dedicated to use only by GSM networks, and these frequency ranges are acquired by mobile network operators through auctioning process conducted by respective local government bodies. Telecom operators pay huge sums to acquire these frequency ranges so that they can use these licensed frequencies to provide telecommunication services to their subscribers. Telecommunication services are further categorized as basic services, which further include barrier services, which provide the users the capacity needed to transmit appropriate signals between certain access points. Teleservices, which provide the users with the necessary capacities including terminal equipment functions to communicate with any other users. Supplementary services, which modify or supplement a basic telecommunication service. Network features further help either in providing additional or advanced telecommunication services to the users, or helps in effectively managing and protecting the networks from potential fraud, abuse, etc. Now let us look at the various telecommunication services offered by GSM networks. Starting with basic services, which include telephony, which is a basic form of service that enables speech conversations. Emergency calls, which are special type of voice calls that are routed to nearby emergency centers to access much needed support as needed. Short messaging services, which include both mobile terminated and mobile originated messaging capability between person to person, and a special type of messaging called cell broadcast. Alternate speech and facsimile group and automatic facsimile group to exchange facsimile documents using GSM networks. General synchronous and asynchronous barrier services to support that data transmission. Voice group call service, which allows a speech conversation among a predefined group of mobile users. Voice broadcast service, which allows the distribution of speech into a predefined geographical area to all or a group of subscribers located in the area. GPRS barrier service that enables packet data transfer. Then comes supplementary services, which modify or supplement basic telecommunication services that are described so far. To start with EMLPP, which stands for Enhanced Multi-Level Precedence and Preemption. Here, precedence is referring to assigning a priority level to a call. Preemption referring to seizing of resources. Preemption can also disconnect ongoing call of lower precedence to accept an incoming call of higher precedence. Call deflection, which enables the mobile subscriber to respond to an incoming call by requesting redirection of this call to another number specified in the response. Number identification supplementary services, including calling line identification presentation, which provides the call party with the possibility to receive the line identity of the calling party, that is, displaying calling number details on the mobile phone screen. Calling line identification restriction that enables the calling party to prevent presentation of its identity to the called party. Connected line identification presentation, which provides the calling party with the possibility to receive the connected number details. Connected line identification restriction, which enables the connected party to prevent presentation of its line identity to the calling party. Call offering supplementary services enable the called number to forward the calls to some other number either unconditionally or when called number is busy or on no reply or not reachable. Call completion supplementary services provide an indication of call waiting in case called number is already engaged in an active call, and call hold facility to interrupt communication on an existing call. Multi-party supplementary service provides a mobile subscriber with the ability to have a multi-connection call, that is, a simultaneous communication with more than one party. Closed user group supplementary service enables subscribers to form closed user groups to and from which access is restricted. Members of a specific CUG can communicate among each other but not in general with users outside the group. User-to-user signaling supplementary service allows a mobile subscriber to send or receive a limited amount of information to and from another user over the signaling channel in association with a call to the other subscriber. Advice of charging permits to display an accurate estimate of the size of the bill which will eventually be paid by the subscriber. Call restriction supplementary services allow the possibility for a mobile subscriber to have a barring of certain categories of outgoing or incoming calls at the mobile subscriber's access. Call restriction services can be applied to both incoming and outgoing calls. Mobile subscribers can select a set of one or more barring programs, which may include barring of all outgoing calls, barring of outgoing international calls, barring of outgoing international calls except those directed to the home country networks, barring of all incoming calls, barring of all incoming calls when roaming outside home country. Explicit call transfer supplementary service enables the served mobile subscriber who has two calls, each of which can be an incoming or outgoing call, to connect the other parties in the two calls and release the served mobile subscriber's own connection. Completion of calls to busy subscriber supplementary service that helps when a subscriber encounters a network determined user busy when dialed, then the network will monitor the called number to become idle and initiate a recall to calling subscriber. Support for private numbering plan supplementary service enables a subscriber to use a private numbering plan for communication across one or more networks with mobile and fixed users. Name identification supplementary service enables the called party to receive the calling name information of the calling party. Then comes network features, which include fraud information gathering system. The purpose of this feature is to enable home network to monitor the activities of its subscribers while they are roaming to detect and identify potential fraudulent usage of services. Immediate service termination enables the home network to control the activities of its subscribers, particularly when they are in roaming. If home network determines, possibly with fraud information gathering system or any other systems, that a roaming subscriber is behaving in a fraudulent or suspicious manner, home network can terminate all activities of the subscriber, including calls that are in progress. Lawful interception. shall provide access to the data sent or received by the target mobile user, such as speech, fax, or data on behalf of law enforcement agencies. High-speed circuit switch data, which allows users subscribing to the general bearer services to access user rates that can be achieved with one or more traffic channels. Operator determined barring, which allow the network operators to regulate the access by the subscribers to GSM services by barring certain categories of outgoing or incoming calls or roaming. Network identity and time zone. This feature provides the means for serving networks to transfer their current identity, time, daylight saving time, and the local time zone to mobile stations to store and present the information to users. Support of localized service area. With this feature, network operators have the basis to offer subscribers different services depending on the location of the subscriber. Tandem free operation. This feature provides the capability to avoid using two different GSM speech codecs in mobile to mobile speech calls to realize the improvements in speech quality. GSM cordless telephony system. This feature provides the possibility for users of GSM terminals to have cordless access to a fixed network. General packet radio service. This feature allows the subscriber to send and receive data in an end-to-end packet transfer mode without utilizing network resources in circuit switched mode. Support of mobile number portability, which offers an ability for a mobile subscriber to change the mobile subscription network within the same country while retaining original mobile phone number. Customized application for mobile network enhanced logic (CAML), which provides the mechanisms to support services consistently independent of the serving network. This feature allows the network operator to provide the subscribers with the operator specific services even when roaming outside the home network. Support of optimal routing, a network feature which enables the calls directed to a mobile subscriber to be routed directly to the mobile subscriber's actual location, bypassing unnecessary home network call legs. Multiple subscriber profile is an optional service to enable mobile subscribers to have several profiles associated with a single SIM and a single IMSI, with each profile being a subscription option. Each profile may be used for mobile originated and mobile terminated calls. This is just to socialize or provide visibility into different types of services that are being offered by GSM networks. To provide the aforementioned services to a mobile subscriber, GSM networks should have a well-designed architecture. Now let us look at the high-level view of GSM architecture. Starting with mobile station, which is used by mobile subscribers to access and use the services offered by GSM mobile system. Mobile station comprises mobile equipment (ME) and the subscriber identity module (SIM). SIM is a removable module and contains the identity of the subscriber. Without a valid SIM, GSM services are not accessible except emergency calls. Next, base station system (BSS), which consists of base transceiver system (BTS) and base station controller (BSC). Mobile station accesses the services provided by GSM network by connecting to base station system over the air or radio interface using licensed spectrum. While BTS serves one cell, BSC controls one or more BTSs. This part of network is generally referred to as radio access network. Then we have network switching system, which typically includes the following entities: Mobile Services Switching Center MSC, an exchange which performs all the switching and signaling functions for mobile stations located in a geographical area designated as the MSC area. The main difference between a MSC in GSM network and an exchange in a fixed network is that MSC has to take into account the impact of the allocation of radio resources and mobile nature of the subscribers, and to be able to support procedures required for the location registration and handovers. Gateway MSC, GMSC, and interworking function IWF. A functional entity associated with MSC provides the functionality necessary to allow interworking between a GSM network and the fixed networks such as Public Switch Telephone Network PSTN, Integrated Services Digital Network ISDN. Interworking function converts the protocols used in GSM networks to those used in the appropriate fixed network. Home Location Register HLR is a database in charge of the management of mobile subscribers. A GSM network may contain one or several HLRs depending on the number of mobile subscribers, on the capacity of the equipment, and on the organization of the network. Visitor Location Register VLR contains all the information needed to handle the calls set up or received by the mobile stations registered in its database. VLR and HLR exchange information during mobile station registration procedure, including supplementary services information. VLR may be in charge of one or several MSC areas. Authentication Center AUC is associated with HLR and stores an identity key, generally referred as KI, for each mobile subscriber registered with the HLR. Identity key is used to authenticate the mobile subscriber and encrypting the communication over the radio path between mobile station and network. Equipment Identity Register EIR contains one or several databases which stores international mobile equipment identities IMEIs used in the GSM system. The mobile equipment may be classified as whitelisted, grey-listed, and blacklisted, so that they are treated accordingly when they connect to network and start using the mobile services. There are other network entities such as SMS Gateway MSC and SMS Interworking MSC to support short messaging services. All these network elements are to support the basic telecommunication services, including voice, messaging, and circuit switch data. This part of the network is generally referred to as Circuit Switched Core Network CS Core, as it operates in the circuit switch mode. Public Switch Telephone Network PSTN is a fixed communications network, and connectivity from GMSC interworking function should facilitate to and from communication between GSM mobile subscribers and fixed network subscribers. When a call is initiated by mobile subscriber to someone in fixed network, call traverses through mobile station, base transceiver system BTS, base station controller BSC, mobile services switching center MSC, and gateway MSC to an exchange in fixed network. In later releases, other entities such as SGSN and GGSN or introduced to support the end-to-end packet switched mode communication to cater the growing demands of data applications. Serving GPRS support node SGSN handles originating and terminating packet data transfer between one or more GGSNs and BSS, while associated VLR handles the subscriber data. Gateway GPRS support node GGSN, a gateway that provides interfaces to other packet data networks, performs routing packets in both directions between packet data networks and one or more SGSNs. This part of the network is generally referred to as Packet Switched Core Network (PS Core). SGSN and GGSN entities leverage functions provided by HLR, AUC, VLR, and EIR, part of Circuit Switched Core Network. When a mobile subscriber initiates a data session, such as browsing the internet, data traffic traverses from mobile station to base transceiver system BTS, base station controller BSC, serving GPRS support node SGSN, gateway GPRS support node GGSN, and then to public data network PDN. Due to the use of radio communications in GSM networks, which are of a special nature compared to classical distribution transmission techniques used in the fixed networks, both the users and the GSM mobile network operators have to be protected against undesirable intrusion of third parties. The use of radio communications for transmission to the mobile subscribers makes GSM networks particularly sensitive to misuse of network resources by unauthorized persons using manipulated mobile stations who try to impersonate authorized users, and eavesdropping of the various information which is exchanged on the radio path. The following security features are considered: subscriber identity authentication. The purpose of this authentication security feature is to protect the network against unauthorized access. It enables also the protection of GSM subscribers by denying the possibility for intruders to impersonate authorized users. Subscriber identity confidentiality provides the privacy of the identities of the subscribers who are using GSM network resources. It provides protection against tracing the location of a mobile subscriber by listening to the signaling exchanges on the radio path. Signaling information element confidentiality. The purpose of this feature is to ensure the privacy of users related signaling elements. This helps in signaling information exchanged between mobile phones and base stations is not made available or disclosed to unauthorized individuals. User data confidentiality. The purpose of this feature is to ensure the privacy of the user information on both traffic channels and control channels. This helps in user information exchanged on traffic and control channels is not made available to unauthorized individuals. This concludes our discussion on GSM, Global System for Mobile Communications. We will continue our discussion further about other 3GPP technologies such as UMTS, LTE, and 5G. You may want to subscribe so that you get notified as and when new videos about UMTS, LTE, and 5G are made available. Thank you for taking time to understand GSM, Global System for Mobile Communications. I hope you find this information useful and please do not hesitate to share this video to others who might get benefited. Once again, thank you and looking forward to the UMTS discussion.